Hmm. All right, everybody. So we're going to start off with the atmospheric transparency and ozone layer questions. So number one, it says basic answers to questions one and two on the cross section below and on your knowledge of earth science. The cross section represents the effect of Earth's atmosphere on on energy from the sun. Arrows labeled A, B, C, D, and E represent some possible paths of this insulation. The dash arrows represent energy re-radiated from Earth's surface. Now, number one says, compared to path D, the amount of energy reaching Earth's surface sun following path B is likely what? Well, let's take a look. All right, and let's zoom in as well too. So when I'm looking at path D, I see there is nothing that is blocking the energy from the sun, right? Sunlight, there's nothing that is blocking sunlight energy from the sun from reaching the surface of the earth. There's nothing blocking it. However, when I look at block path B, there is something that is in its way. What is it? A cloud, right? And what do we know about clouds according to our notes? Okay. So we know first off, there is something that is going to be blocking path B, right? So that means the amount of energy, right, that's going to reach the Earth's surface going the path of B is going to be less. So that means it can't be C or D. We know it's going to be less because there's a cloud in the way. Now, what do clouds do? If we take a look in our notes, all right, let's just keep scrolling, keep scrolling. But if you take a look in your note sheet, we mentioned it right here, all right, where we stated it right here. What are the things that can reduce, meaning to make smaller, the atmospheric transparency? And clouds is number one on that list, right? So atmospheric transparency, if we forget, talks about, describes how easy it allows for insulation to reach the Earth's surface. So because there's a cloud in there, that means clouds will reduce the atmospheric transparency, making the answer choice one. The atmospheric transparency is going to be less. All right. All right, number two. Number two states as follow. It says, which arrows represents reflected insulation? All right, so that means I'm going to look at the diagram and where do I see lines that are being bounced back up? Okay. Well, there are two letters that I see that's being bounced back, A and E. And we know that clouds are reflecting some of that insulation. And we know there may be some material on the ground that could reflect insulation, right? If we remember our notes, it could be snow that's on the Earth's surface, it could be sand that's on the Earth's surface, but there's definitely something on the Earth's surface that can reflect some of that insulation. So path A and B and E, sorry, path A and E are the only ones that are showing lines that are bouncing back into the atmosphere. All right, number three says during explosive volcano eruptions, large amounts of ash entering Earth's atmosphere often rise to an altitude of 20 kilometers. Keep that in mind. What is the most likely effect of this ash cloud? Was the most likely effect of this ash cloud? Okay. So when I'm looking, it says a decrease. When I'm looking, let me see what options that I can cross out. So when this ash cloud came in, right? I'm looking at some of these options. C, we can cross out. Why? Because C is saying that with an ash cloud, there would be an increase in the insulation. If you have a volcano and it erupts and is giving ash clouds, isn't it blocking insulation, right, from reaching the surface of the earth? right? Isn't the ash clouds blocking it? So there wouldn't be an increase in insolation. It'll actually be a decrease in insolation. We can cross out an increase in the thickness of the Earth's stratosphere. There is nothing here that would change the stratosphere layer. So it can't be B or D. All right. Well, we're even talking about the stratosphere. It's mentioned right here, and I'll clear this out. This is the stratosphere. There is nothing currently right now that something would happen to change the actual stratosphere, right? This is the stratosphere. So no, volcanoes erupting is not going to now widen or make the layer smaller. All right. So that's something to keep in mind. Let me see what else. Okay, number 4. Number 4 says, oh, so yeah, we're gonna do number 4 too. Sorry. Oops, before I get to that. The correct answer was actually A. All right, I do apologize for that. All right, number 4 says atmospheric transparency will increase. So when they're talking about atmospheric transparency, what they're talking about is how clear the sky will be, right? And especially if they're talking about if you want atmospheric transparency to increase, that means we need clearer skies. All right. So when a volcano eruption occurs, it's going to bring ash clouds. No. If a fog is being produced, that means there's a lot of moisture in the air. No. Insolation is reflected by clouds. Key word, you got clouds in the sky. So that means the sky is not clear, atmospheric transparency will not increase, and you're left with D. The precipitation removes dust particles from the air. The fact that it's removing something from the air that can reflect or bounce back insolation, that's the reason why D is the correct answer. All right. Because if it's removing particles in the air, then therefore it's going to make the sky more clear for insolation to come down and reach the earth. All right, so number 5, it says, base your answer to the following questions on the passage and diagram below and or your knowledge of earth science. The diagram represents a house located in New York State. All right. And so the reading talks about the solar heating. So it says solar collectors in solar heating systems harness the power of the sun to provide thermal energy for heating hot water and house interiors. There are several types of solar heating systems. The best system will depend on the geographic location and the intensity of the sun. A solar heating system saves energy, reduces utility costs, and produces clean energy. The efficiency and reliability of solar heating systems have increased dramatically in recent years. And they give us a diagram of a solar collector on a house. And the question says, explain why solar energy can still be collected on cloudy days. All right. The reason for that is because clouds only reflect some of the energy back into space. All right. So that's something to keep in mind. Clouds don't reflect all of the energy, they only reflect some. That's why even when it's cloudy, right, we can still see, hey, it's daytime, right? It's not nighttime, right? Because clouds only reflecting some of the energy back into space that comes from the sun. So that's something to keep in mind. All right, number 6, it says, number 6, it says basic answers of questions 6 and 7 on the passage below. 6 and 7 on the passage below. Let me see, sorry. And so they give us a reading, right? In the reading, there's one important thing. It says a concentrated ozone layer between 10 and 30 miles above the Earth's surface absorb some of the harmful ultraviolet radiation coming from the sun. All right. And then it says the amount of ultraviolet light reaching Earth's surface is directly related to the angle of incoming solar radiation. The greater the sun's angle of insolation, the greater the amount of ultraviolet light that reaches Earth's surface. If the ozone layer were completely destroyed, the ultraviolet light reaching Earth's surface would most likely increase human health problems such as skin cancer and eye damaging. So automatically, we'll start at number 6 first, but even with number 7, I want to do number 7 actually first. It says explain how the concentrated ozone layer above Earth's surface is beneficial to humans. They tell you right here that the concentrated ozone layer, which I underlined, it absorbs some of the harmful ultraviolet radiation coming from the sun. And it tells us right now that if that ultraviolet light reaches the Earth's surface, it would most likely increase human health problems. What I just underlined, basically, especially in red, is your answer for number 7. It protects us from harmful ultraviolet radiation. That is the benefit for the ozone layer. It protects us from harmful ultraviolet radiation. All right. Which means that this ultraviolet radiation could cause skin cancer and eye damage. Okay. Last, number 6, it says, state the name of the temperature zone of Earth's atmosphere where the concentrated layer of ozone gas exists. All right. The temperature zone of the Earth's atmosphere, they're also just asking for the layer of the atmosphere. All right. Layer of the atmosphere. They tell us the concentrated ozone layer occurred between 10 and 30 miles above the Earth's surface. Okay. So therefore, when I'm looking at my page 14, right? When you look in the miles section, I'm looking at 10 miles, right? If each line goes by 5, 10 miles is here, 30 miles is here. So from 10 to 30 covers this layer, okay? And you see the word temperature zones, right, of the Earth's atmosphere is just describing the layer of the atmosphere. And so what is the temperature zone? What's the name of this temperature zone? It is the stratosphere. All right, so the correct answer for number 6 is the stratosphere. Take care and have a wonderful day.